In this tutorial, we're going to look at adding in and animating some of the basic primitive objects inside of processing. So we've already done an ellipse. We'll redo that one. We'll also add in a circle, a rectangle, and a triangle, so we can start to understand how to work with all these different objects in our program. We're also going to discover along the way that if we don't have a better system, having multiple objects inside a single program all animating independently is probably going to start to get unwieldy once we get past a handful of objects. But this is how we learn with this. So as always, we have our variable section where we define things that we're going to need in our program. We have our setup, which is where we initialize everything for our program, and draw, which is going to be our repeating loop that happens approximately 60 times per second. So previously we had an ellipse. Now we're going to also add in a circle, a rectangle, and a triangle. So as we add in each of these objects, each object is going to need its own variables. It's going to need to have them defined in setup, and then we're going to have to work with them in draw, and each of the objects is going to have to boundary check. And what we're going to learn along the way is that there probably is going to be a better way to manage all of this, and that's what we will be moving towards in a subsequent tutorial. So right now we'll repeat what we did with the ellipse, but we're going to have to update our naming here a little bit, and instead of just having X for it, because we can't have an X for the ellipse and an X for the circle, we have to designate what they are. So because ellipse, circle, rectangle, and triangle all start with separate letters, I'll just go EX. And one thing that we are able to do is variables that are of the same type, the same kind of thing, we can't put them on a single line. So I can define these this way. And notice, I am using a version of camel casing to try and make this a little bit easier to read, because if we do like this, it's like speedy. That doesn't seem to work as well as speed Y. So we're going to be repeating that now, and we'll do CX, CY, CW, CH, C speed X, C speed Y, and repeat that for the rectangle. RX, C, RY, RW, RH, R speed X, R speed Y. And finally, int TX, TY, TW. Well, triangle doesn't actually have a W and H, because the triangle is composed of separate points. So once we know what our origin point is, then we offset the points based on that. So we only need an X and a Y to go with that, but it will need then our speed X and speed Y values to go along with it. So then it will be, oh, and I missed capitalizing the S right here. But we'll go T speed X, T speed Y. So we can shorthand defining these here, but when it comes time for our setup, we will have to put each one on its own line. But hopefully that's going to keep your code a little bit more legible. And we'll just use the standard 800 by 600 here. And now start defining our values. So I can just choose a random number here. We'll just start it out at 100. Oh, but I got to capitalize it. EX is equal to 100. EY is equal to 100. EW is equal to, this time for the ellipse, we'll make it asymmetrical, so I will say that it is 100 wide, but only 50 tall. And then E speed X will be equal to, and with these I'm just going to keep updating the values on it. So I'll start out with 2 here. E speed Y will be equal to 4. That was our ellipse. Now I can have my circle. So this is a little bit repetitive that we have to go through this and define these, but that is just the nature of our situation. Now we have CX. We'll set this one equal to 100 as well. So we'll put all their X's at 100, but we'll just start moving the Y's down. Start the CY at 200. And I forgot, circle doesn't have a width or height. Circle really just has a radius, so it should be R, because it only takes one value. Where the ellipse, because it can differ, a circle being round, only needs a single value. So with that, it will be CR is equal to, in this case, I will just go 100. And then C speed X is going to be equal to 6. C speed Y will be equal to 8. Our rectangle here, my Rx is going to be equal to 300. Oh, sorry, 100. Our Y will be equal to 300. And then my RW is going to be equal to, we'll say 50, and RH is equal to 100. R speed, and I could copy paste some of these things and then just put in the R's and the C's and the E's, etc. Or we can just type it, it's all fine. And then our R speed Y is going to be equal to 12. We'll probably have to change some of these because that's starting to get awful fast. Now our triangle, TX, we'll set that equal to 100 as well. Our TY, we'll set that equal to 400. And then our T speed X is going to be equal to 12 is starting to get really, really fast. So we're going to just slow the triangle down and we'll go for an odd number. T speed Y is equal to 5. It is possible as we do this, we could have random numbers for our speeds or a range. We could set a random number within a range, so we could possibly even have a positive or negative number, so it initially starts out going left or right or up or down, but we'll save that for a future session. So right now I have defined all of my core variables, and now we get to start working with them. First thing we want to do on our draw is going to be clear everything. So we can do that with the easy command of background. And in this case, I'll just choose a basic gray. We'll worry about colors later. And I'm just going to set a basic fill color for everything can go customize as you see fit your objects, but I'm more concerned about drawing the objects on screen and then animating all of those objects on screen. So we'll just fill them with middle gray. Now, the first item that we have here is our ellipse. So we can just simply use the command we used before. Ellipse, EX, EY, EH, EW, EH, and then EX is equal to EX plus E speed X. EY is equal to EY plus E speed Y. Now if we run this, let's see what we get. We can see how now it's moving. We don't have any boundary check happening yet, so we do need to put in our boundary check to figure out what is happening. So adding the boundary check for the ellipse. Now we could have copy pasted or just started with the code from the previous one, but I figured it was just good in the beginning here to repeat things, to rehash it, just to make sure that we have an understanding of what is happening. So this is our bounds check, and with that we if x, and remember because the ellipse draws from the center, we have to add in half of its width, otherwise it goes halfway off screen. So common typo is when you're typing width to flip-flop the TH, so do make sure that you do it correctly. If it doesn't turn pink, you probably did it wrong. So to returns, curly brace, up arrow, speed x is equal to speed x times -1. And I missed the x on my first value. And now looking at this, I missed all kinds of things because it's EX, EW divided by 2, and then it's E speed, E speed. Now this is where I can copy paste it here. Change the y's to y's, w to an h, and then this will be height. So now if we run it, we should see it's bouncing. Oh. Sometimes, yeah, we need to think a little bit better and not. The copy paste would be if I was repeating this for a different. I forgot. It's not exactly. All right. So actually, no. This one is correct here. I just forgot the else's. So I was thinking ahead to how I could speed up what I was doing for the next object, and in the process of doing that I wasn't fully paying attention to what I was trying to do here. So we first add the width and then we subtract half the width here. So if the x minus half the width is less than 0, meaning we hit the edge, curly brace, return twice, close curly brace. So this is our horizontal check. Now this I can safely copy paste in because it's doing the same thing. And now here, else if, and we want to do EY minus EH divided by 2 is less than 0, meaning we hit the top of the screen, curly brace, return twice, close curly brace, up arrow, and simply copy that, paste, Command Control T to auto format, cleans all of that up. And now if we run it, we should see it bounces on the bottom, bounces on the top, bounces on the right, and now we just have to wait for a few more bounces before it gets to our left edge. And it is working. Okay, so we have our first object done. Now, when we do the circle, we're going to look at a couple optimizations we can do of refactoring our code to just make it a few less lines to type, learn a couple extra cool programming concepts along the way so we can be a little more efficient with our code. So that's what we're going to work on. And let's see, is circle next? Yep, circle. So now we will draw the circle. So with the circle, the first thing that we can do is just simply say circle, and it's CX, CY, CR. Now let's run it and see, do we get a circle? And there is our circle parked there waiting to animate. So this is where we get to animate it. So the first thing we're going to do is we are going to shorten up our line of code. So instead of saying CX is equal to CX plus C speed X, what we can do is say CX is or say plus equals C speed X. So these two lines are equivalent. So line 65, CX is equal to CX plus speed X, is the same. It generates the same result as saying plus equals. So plus equals is the shorthand way of writing this. So it's a little bit shorter. Just have to make sure you do plus equals. Advantage of doing this is when we do it this way, there's fewer things you're typing. Every time you're typing less characters, one, it's faster, two, that's fewer chances to make a mistake. So when it makes sense in our code to optimize what we're doing to be more efficient, it's probably going to be better. We still want to be verbose enough that our code is human readable, but I'm just going to comment this one out. But what we can do is now go CY plus equals C speed Y. And the cool part is we can use plus equals, we can use multiply equals, minus equals, divide equals. So it's a really efficient way of working, and well, we're going to be using that times equals here in a little bit. So this is our first optimization. So now I'm going to run my code again and make sure it works. Yep, it works, and then the circle disappeared. Okay. So you will notice I type some code, I run it, type some code and run it. Part of that is to make sure if I type a whole bunch of code and then hit run and it doesn't work, I don't know where it broke. But if I type only a few lines of code, run it, and if it's broken, it's much easier to then hunt down where it broke. So my preference is always going to be to try to just do a little bit at a time. So this will be our circle bound check. So with this, we're going to learn something else new here. So instead of using our if and else, if we recall here, speed x is equal to speed x times minus 1. Speed x is equal to speed x times minus 1. So we can actually simplify this so we only have to put that in once. And we do that by saying if And if we say, so if Cx plus CR, in my head I always want it to be R, but it's actually the full width, so technically R is, the proper term should have been D for diameter, not R for radius. So sorry for the confusion on that. So we do need divided by 2 there. So if that's the case, and then we'd say greater than width. So that gets us to the one edge. We can also then say, so if our circle has hit the right side, so it's greater than the width, or our circle has hit the left side. And the left side is simply going to then be Cx minus CR divided by 2 is less than 0. Whoop, 0. Curly brace, return twice, close curly brace. So when we use this symbol here twice, the vertical pipe, that is how we write the word or in programming. So if we wanted to say if we needed both of these to be true, which could never happen, we use double ampersand. So we're saying and. So if this and this other situation, but in this case we want the vertical pipe, which is right above the return key and below the backspace or delete key. We have the vertical pipe. So on the right side of your keyboard, near the top, you have the vertical pipe. So if this situation is true, or this other situation is true, then at that point we just simply say C speed x times equals -1. So we've shortened 1, 2, 3, 4, 5 lines of code down to 3. And I would say in some ways we've made it a little bit more readable. Now we can repeat that process for a vertical check. So if cy plus cr divided by 2 is greater than height, or cy minus cr divided by 2 is less than 0, meaning we hit the top of the screen, curly brace, return twice, close curly brace, up arrow once, C speed y times equals -1. And, I hit X, which is right next to C on the keyboard. I was like, why is that red? But now we can see. So now if we run this, we can see how the circle is indeed bouncing off of the edges of the screen. So we've used or, we've created a compound conditional. So we're saying if one of these two things is true, then make this happen. So I would argue that by putting it like this for the circle, it's a little bit cleaner and easier to read than what's happened for the ellipse, and it's certainly fewer lines of code, which is quite nice. Now we're going to draw the rectangle. The rectangle's boundary check will be a little bit different because unlike the circle, the rectangle draws from its middle, from its top left corner, not its middle like circles and ellipses. So now to make our rectangle, we just simply say rect, R-E-C-T, and then our x, our y, our w, our h. Now if I run this, we'll verify there's our rectangle. Okay, so now to animate the rectangle, our x, and then it's plus equals, our speed x, our y, plus equals r speed y. If we run this, we'll see the rectangle, oh, gone. And the rectangle's gone very quickly because, of course, it has very fast speed components as part of it. So now we need to throw a little bit of boundary check for that. So rect bound check. So if, in this case, our Rx, so if our Rx, remember it's measuring from its left corner. So if our Rx, well, first we're just going to start out, I'm going to turn off the Y so it goes only horizontal so we can see. So if Rx is greater than width, and we'll add in the rest of the compound conditional in a minute, a couple curlies, returning, and then with this r speed, oh, missed my capital, speed x, and that's times equals -1. So if we watch this, and I'm going to slow the rectangle down because it'll be very hard to see if it's moving at 10. We'll just put it at 5. Now let's run it. We'll watch the rectangle go, and it goes all the way off screen, and then it comes back. So it, oh, and then it disappears because we didn't check for the other side. So what we need to do is we need to add plus RW. So now if we run this, let's see it work. We'll see the rectangle go, and it bounced off the margin. Now remembering that it draws from its left corner, we can just simply say or Rx is less than 0. So we don't have to add anything because it's not drawing from its middle, it's drawing from its corner. So we'll watch this rectangle go and bounce. Perfect. So that now gives us our horizontal. So if our y plus our h is greater than height, or our y is less than 0, close parenthesis, curly brace, return twice, close curly brace, up arrow, r speed y times or multiply equals, so it's the star key. That is the symbol we're using for multiplication. And let's go give back its vertical speed and run it. And now we'll see how it's ping-ponging very quickly off the ceiling. So we have an ellipse, a circle, and a rectangle all animating, and each one is animating independently. So you can imagine if I said animate 100 objects on screen, how unwieldy this would become. And we are going to be looking at then how we can be more efficient when we want to have lots of objects animating on screen so we don't end up going insane writing duplicative code, because that's just way too repetitive. Our final object that we're going to work with is going to be the triangle. Now the triangle is a little bit different when we work with it, and that it has 3 points defining it. So we can just simply say tx, ty, and the next 2 points, because that defines, this is the first point of the triangle. So in this case, I'm going to let this be the top of the triangle. So now if I want to draw in a clockwise manner, I'm going to move over some amount. So I'll say tx plus, and I have to think about how much I want to go over. In this case, I am going to go over 50. And then we'll go ty, and we're going to go down. Well, we'll just, plus 50. And then our next point, t, will be tx minus 50. But it will still be down 50, so I'll go ty plus 50. So now if I look at this, let's see what we get on screen. You can see there is my triangle. Now it's going to get a little bit tricky doing a boundary check on the triangle. But first, what we can do is just simply say tx plus equals t speed x, ty plus equals t speed y. Now if we run this, you can see that the triangle is working. So the thing to keep in mind here, and I'll auto format to clean up my spaces, is that the first point is the top of the triangle, then I have the right point, and then I have the far left point. So we're working our way down, and those other 2 points are defined in relation to the first point. So 1 point is kind of the origin. Now I could do a little bit of math, and I could have tx and ty represent the center of the triangle, and then my top point could be offset from that. So I could even say that the x, that is centered, but the y, because that is the top, I could go minus 50. And I'm going to just turn off the speed or animation for a moment. Now we'll run it again, and we'll see there is our triangle. So to further illustrate what is happening, I will just simply draw an ellipse at tx, ty, and we'll just make it 4, 4. Should have done a circle, and then I would only need 1, 4. But we can see there is where that point is. So here is that point tx and ty. This point is up 50 from that. And it may not look it, but it is centered. So the distance between the apex of the triangle and here, and from that dot to the bottom, is indeed the same distance. It's just because there's so much more down here, it creates the optical illusion that that distance is shorter, but they are the same. So you can see we can either have a center point and draw the points in relation to it, or whatever you want to do. But now to do our triangle bound check, to accomplish this, so first we'll do our horizontal. So if tx, so we know tx is in the middle, and the right point and left point are 50 over, so tx plus, in this case it's 50, so we will hard code that number in because we don't have kind of a width or a height, we just put those numbers in down here. So tx plus 50 is greater than width, or tx minus 50 is less than 0. Returns, close out my curly, then we can just simply say t speed x times equals -1. And I see a little red line here that's telling me that it's unhappy with my code here. And I realized that I forgot to capitalize. It says tx does not exist because it's t capital X. That's a camel cased version. Now let's work on the y value. So if ty, in this case ty plus 50, because remember, so I guess, instead of hard coding all the 50s down here, we could simply, I'm going to just set this as a th. And I'm going to change these 50s here to a tw. Well, let's get it working first, and then we'll go back and make that change. Tx plus 50 is greater than height, or, ty, or ty minus 50 is less than 0, close parenthesis, curly brace, return twice, close curly, up arrow once. Someday I might stop saying that, but I do find that by putting in your closing curly and just running that through in your head every time until it's drilled in will prevent so many errors in your code down the line. So if you just get in the habit of doing that, so that's why I'm just trying to kind of burn that into your brain. So I'm not trying to be annoying with that, just trying to get that point across. Oh, and now we have to turn back on the animation of the triangle. So do notice this is a handy way of working with your code, is you can just quickly, so I just highlight these two lines, Command or Control / comments it out. The same procedure uncomments it. And now the triangle is bouncing around on screen. Perfect. Now, as I said, we're going to give the triangle height and width after all, even though we didn't initially. So I will just add those in. TW, TH, and then in the triangle, TW is equal to 50, TH is equal to 50 as well. And again, you can change these numbers, and then, because now, if I want to make my triangle different and a different width or different height, I have to go through and change all these numbers in here. And hopefully this helps to illustrate to you why using a variable is going to be so much better. So now, in this case, y values will be using TH. So I'm going to just change all my y values right here, TH, TH. And those are x's. TH and TH. Now we'll go to our TWs. TW, 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 and finally TW. So now if we run the code, it should still perform as before. Let's see, the triangle bounces on all four edges. Let's make sure it hits the left edge and works. Excellent. But the beauty is now if I want my triangle to, we'll just change the height here. We'll go to 20 and change the width to 80 and run it. You can see I changed it, but I didn't have to change anything later on in my code. So your programs ideally should always be configured so that what you're changing is happening in your setup or your initialization portion of your code, and in your code that is looping or running, that should just be referencing variables, so you don't have to go and hunt through like I had to go change all those 50s out. If I wanted to change the width of my triangle each time, it would be a colossal pain if I had to keep changing the numbers through all of these, and invariably I'd miss one and break my code. So this is indeed a better way to work. So I'll leave it to you to customize this with proportions and shapes and speeds and colors and make it fun. Good luck and enjoy coding.